Welcome back. This week we're going to be talking about reading digital buttons. Before we get started, we should really think about the two different options you have when reading digitally. You're either going to see high or low. However, we should address right now that there are a number of ways to say high or low, depending on the variable type you are discussing. High is equivalent to 1 or true. All three can be used interchangeably. Low is equal to 0 or false, and again can be used interchangeably. The first thing we should discuss when wiring a button is how to bring it to one of the two discrete states on that digital pin. Now, unless you set it specifically, it is going to float somewhere between high or low, and you're going to get really erratic readings from it unless you do something to either bring it down to low or up to high. So firstly, let's note that buttons need to straddle the bridge on your breadboard such that each of its pair of legs are separate from one another. In the instance on the left, what we are going to do is pull that button down to ground. So essentially what we will have is power feeding one leg, and we will be bringing the second to ground using a 10,000 ohm resistor. The jumper wire that comes off of this leg will basically read the path of least resistance. At the moment, this is an open switch when it isn't being pressed, so it is going to be read that it is going to 0, and you will get a reading of 0 when you're not pressing your button. Upon pressing your button, the path of least resistance will take you now to the high power line, and at that point you will read a 1 when you are pressing your button, because this 10,000 ohm resistor will not allow that reading to be going in that direction. In the instance on the right, what we are going to do is bring one of our legs to ground and a jumper wire over to the other leg. In this case, we are going to have to, through software, pull that reading up using an onboard pull-up resistor so that when the button is not pressed, it is going to be reading a 1 or a high. Upon pressing the button, we would close the switch, bringing it to ground, and in that case we would read a 0. So you can hardwire it with a pull down resistor. When the button is not pressed, it will read a 0, and when it is pressed, it will read a 1. Or using a software based pull up resistor, when the button is not pressed, it will read a 1, and when it is pressed, it will read a 0. Alright, before we get into the code of this, I want to point out that I've added two LEDs on the board in order for you to visualize the state of the buttons when we are pressing them. The way that they are wired is identical to the way that we have done them in the past. Now, I have used a color convention in the color of the jumper wires that I've selected here. The red wire coming off of this button is going to control the red wire that is going into this LED. The green jumper coming off the second button is going to control the green wire going into the green LED. So the convention of naming I'm going to use is red button, red LED, green LED. So now let's take a look at the code. The first thing we need to do, as usual, is set some global variables up at the top to hold the location of my red and green buttons and my red and green LEDs. You can see from the wiring diagram on the left where they've been plugged into. Red button is plugged into 2, green button into 3, red LED into 4, and green LED into 5. I could have absolutely used arrays in this case, however I thought it would be easiest for right now to break them out as individual variables. The next thing we need to do in the void setup portion of the code is initialize our hardware. So the first thing I'm going to do is open up the serial monitor on line 8. I am then going to set the pin modes of both of my buttons. Now this is where things can be interesting. For my red button before, which I wired up with a pull down resistor, I am simply going to declare it as an input. For my second button, the green button, the one which I told you I would from a programming end access the input pull-up resistor that is located on the digital pins of the Arduino, I have to use a slightly different syntax. So the pin mode of my green button is going to be set to an input, but I'm going to include the underscore and the word pull-up to indicate that I want that button to be set high when not being pressed. The pin modes of both the red LED and green LED are outputs as usual. Now we'll head into the void loop, which is going to have the reproducible part of our code. So the first thing I'm going to do on lines 17 and 18 is declare two integer variables, each to hold the state of the buttons that I am observing. So I'm going to have a red button state, which essentially is just looking to see if the button is pressed or not. And it is going to be set by calling digitalRead and the red button, which is the pin that my button is attached to. On line 18, I'm going to do the same exact thing for the green button state and set it equal to the digital read of the green button, keeping in mind now that a digital read is looking for one of two discrete states, 1 or 0, high or low, true or false. Remember, these are all equivalent values. What I'm going to do next on lines 19 through 22 is simply make a couple of serial print calls so that I can visualize the states of my button on the screen. So in line 19, I'm going to print the string red button so that I can identify it from the other. On line 20, I'm going to print the actual red button state, either 0 or 1. On line 21, I'm going to write the string green button. And then on line 22, I'm going to print the state of the green button, again, either 0 or 1. As an extra manner of visualization, I'm also going to use the digitalWrite function for the red and the green LEDs. And what I'm going to use, instead of hard coding in the value high or low, I am going to use the current condition of the button state to set the state of the LED that corresponds to it. So on line 23, I'm going to digitalWrite the red LED to whatever the state of the red button. So when we open up, remember, that's using a pull-down resistor. So when that button is not pressed, that value will be 0 or low, and the red LED should be off. When I press the red button, that state will go to high, and that will turn the red LED on. Oppositely, with the green LED, this is using an input pull-up resistor. So when that button is not pressed, the state of the green button is going to be high, and the green LED will be on. When I press the green button, that will bring it back down to ground, setting its state to 0. So when the green button is pressed, the green LED should turn off. Now at the end of this code is a slight delay to improve the simulation performance. And here for the first time, we have what's called a comment. Comments are little footnotes that we can add to our code to let us know why we've made certain decisions. They are preceded by a double / and are completely ignored by the compiler. They are only for human eyes, and they are really helpful when we are first learning to code. So let's go ahead and simulate our code to see how this all works. So I'm going to begin the simulation. I'm going to open up the serial monitor, and I want to point out here that at the moment, the red button is not being pressed, and it has a pull-down resistor, so you'll see that the value of the red button is 0. The green button, which is using an input pull-up resistor and isn't being pressed, currently has a value of 1. If I are to go ahead and push the red button now, you will see that its state comes up to 1 as I've now closed the circuit, and you'll also notice that the red LED has turned on because remember, I'm setting the LED state to be equal to that of the red button. Now I'm going to have to move my code out of the way for the next portion. I've just let go of the red button, by the way. You'll see its state went back down to 0 and the red LED went off. Let's take a look at the green button. Currently, the green button is not being pressed, but this is an input pull-up resistor, which means its current state is high. Therefore, the green LED is on. When I press the green button, I will bring its state to ground, making it 0, thus turning off the green LED. A really excellent way to demonstrate digital read and digital write.